The International System of Units is scientists' way of being able to communicate worldwide in kind of like the same language. And so I think we've talked about this before, so this should be a quick review. So a measurement is a quantity that includes both a number and a unit. And there's a couple different measurement systems. We have the English system, which is what we're most familiar with here in the United States with the mile and the pound and inches and feet. And then we have the metric system with centimeters and kilograms. And then we have the SI system. This is the international system. Of units. And so the SI system uses base units, and the table below here shows you what the base unit is for each of the different quantities. It's based on the metric system, and it was adopted by an international agreement in the 60s, and there are 7 base units. So for length, we have meter, mass is kilogram, temperature is Kelvin, time is in seconds, the amount of a substance is mole, electric current is measured in amps, and luminous intensity is the candela. And so with each of those base units, we can add prefixes to them. And so this table here shows you a list of prefixes. It shows their abbreviation, their value in exponential, so 10 to the whatever, and then how that works out mathematically, and then an example of them. And so, again, I believe you should be familiar with this table. Scientists also use scientific notation. We've worked with scientific notation before. This is ways to express really large numbers or really small numbers. And so this is a way we write numbers as a product. We use a coefficient and a number times 10 raised to some power. So when we look at the sample problem, we need to have our first number has to be between 1 and 9.99 repeating. So the decimal is originally back here. In order to satisfy this first rule, we have to shift this decimal all the way up to between the 1 and the 5. So we have 1.5, multiply it by 10, and then now we need to figure out the value of the exponent. And to do this, you start where you put the decimal, and you need to move it back to where it was originally, and you need to count how many spaces you moved it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our exponent would be to the 11th. Now to take a number out of scientific notation, you take the number in front of the decimal, and then you look at this exponent. Here we have to the -7th. That negative indicates we move the decimal to the left, and we need to move it to the left 7 places. So we go 1, 2, 3, 4, 5, 6, 7. Place your decimal, and in each one of these little swoops, we put a 0. So our final answer would be 0.60913. Length and volume. The SI unit, basic unit of length, is the meter. Its abbreviation is M. And volume refers to the amount of space occupied by a sample. However, the SI unit is meters cubed. Liter is the volume of a cube that measures 10 centimeters on each side. So 1 liter equals 1,000 centimeters cubed, or 1 decimeter cubed. Mass and weight. Mass is the measure of the amount of matter that is in an object, and our SI unit is kilograms. Weight is a measure of force, that is equal to the gravitational pull. It is dependent on location, and by location, I'm talking more so like location within space. Our weight on Earth doesn't fluctuate much due to gravity. It will a little bit, but not by much. So big thing here, weight is location dependent, mass is not. Temperature and energy, we've talked about this before too. Particles in hot objects move faster than particles in cooler objects. This is your kinetic energy, which is the energy due to motion. So our kinetic energy will increase when temperature increases. Temperature is the measure of average kinetic energy of the particles in matter. Heat will always flow from objects with high temperature to objects with lower temperature until we reach an equilibrium. And we have 3 temperature scales, Fahrenheit, Celsius, and Kelvin. Kelvin is based on molecular motion. And remember, with Kelvin, we have the absolute 0. And at absolute 0, all molecular motion stops. Couple formulas over here to help you convert between Kelvin and Celsius. And then lastly, we have energy. Energy is the capacity to do work or to produce heat. There's kinetic energy, which we just said was the energy of movement. Or we have potential energy, which is energy that is stored. And our SI unit of energy is the joule.